Question number 6. The first three terms of an arithmetic progression are p square over 6, 2p minus 6 and p. These are three terms of arithmetic progression. Given that the common difference of the progression is not 0, find the value of p. Before solving this question, I am giving you an example of arithmetic progression. This is an example of arithmetic progression 1, 3, 5, 7, 9 and so on. This is an arithmetic progression because the difference of any two consecutive terms is same. Look at this second and third term. If we subtract 5 minus 3, this is 2, and taking these two terms, fourth and third, 7 minus 5 again 2 and so on. Such types of progressions are called arithmetic progressions. Difference between any two consecutive terms, for example 5 minus 3, just same as 7 minus 5. So the given terms of arithmetic progressions are p square over 6, 2p minus 6 and p. So we have to find the value of p. First term is arithmetic progression. First term is p square over 6. Second term is 2p minus 6 and third term is p. These are three consecutive terms. So common difference between any two consecutive terms will be same. Mean this is the second term. Second minus first will be the same as third minus second. So we can write 2p minus 6, second term minus first term is p square over 6, same is equal to third term minus second term. Now we will solve this equation to find the values of p. We can write 2p minus 6 minus p square over 6 is equal to p minus 2p plus 6. Right hand side become minus p plus 6. Left hand side we can take LCM. LCM is 6. So we can write 6 LCM. 6 to 12, 12p minus 36 minus p square. Now we will cross multiply. Cross multiplying we get 12p minus 36 minus p square is equal to 6 into minus p plus 6. Simplifying it, 12p minus 36 minus p square is equal to minus 6p plus 36. Further simplifying, we get p square minus 12p plus 36 minus 6p plus 36 is equal to 0. Now from here we get p square minus 18p plus 72 is equal to 0. Factorizing we get after factorizing we get two values of p. Now factorizing p square minus 12p minus 6p plus 72 is equal to 0. From here p minus 12 minus 6 into p minus 12 is equal to 0. This shows that p minus 12 p minus 6 is equal to 0. So we get two values of p. P is equal to 6 and p is equal to 12. Now, but we have to find the value of p. There will be only one value of p which satisfies the arithmetic progression. Now it is given that a common difference of the progression is not 0. So we have to justify which value is valid, which value is not valid. Now putting these two values of p here, putting these two values here, we get, because if we put this value as 6, this will not satisfy the given arithmetic progression. P is equal to 6 will not satisfy the given equation, given arithmetic progression. So this is not applicable. If we put here 6, if we put here the value of p 6, so we get the common difference is 0, because this is 6, 2p 12 minus 6, that is 6, or p square over 6, this is also uh, 6. 6 minus 6 that is 0. So common difference is 0, but the common difference is not 0. It is given in the question statement, so we neglect this. P is equal to 6. Only the answer is p is equal to 12. Now next part of this question is, using this value, find the sum to infinity of the geometric progression with the first two terms p square over 6 and 2p minus 6. Now these are two terms of the uh, first two terms of the geometric progression. Now this is GP, geometric progression. First two terms are p square over 6. This is the first term. Second term is 2p minus 6. Now putting the value of p which is valid, that is 12, putting here the value of p, we get 12 square over 6, 2 into 12 minus 6. So this will become 24. First term is 24, second term is 18. 24 is the first term of the GP and second term is 18. So we have to find sum to infinity. Formula to find the sum to infinity is S infinity. We write it as S infinity means sum of infinite terms A over 1 minus R. Now A is the first term which is 24, and R will be, common ratio will be second term divided by first term. So here A is equal to 24 and R is equal to 18 over 24, that is, after simplifying 18 over 24 we get 3 over 4. So putting these two values, R is equal to R is equal to 3 over 4. This is common ratio and first term is 24. Putting here we get sum of infinite terms. S infinity is 24 over 1 minus R is 3 over 4. After simplifying 24 over 1 over 4, this 4 will be multiplied by 24. 24 into 4 will be 96. So S infinity is equal to 96. This is the answer.